Send
Cool.
out a reminder on my stuff.
hmm
Yeah, I can
Oh, this
definitely
is
tell a difference with your microphone. That's awesome.
cool. So we have Abid's notebook and we have the Titanic data set for today, right?
Yep.
Yeah, let me fire up Abid stuff. Mhm. Oh yeah, but it's your fork. You have your. Can you share the link
Yeah.
to the one that is currently open into the chat? Cool. Cool. And cool.
Might not be higher quality audio, but I feel like it should be. I got a lot more chords in front of me this time than I had last time. More
I think it's
monitors,
okay.
too.
Cool, cool. Are you at home, by the way?
Yeah.
Cool. Okay. Um, yeah, everything's open here. Should we start with something?
Yeah, I was looking at. We did have a comment? I don't know.
Hey, Dulilo. Great to see you too.
All right, yeah, we can start talking about stuff and we'll just kind of start at least with some light chat about the general topic and then we can kind of get into the specific notebooks as people join. So, what we wanted to talk about a little bit today was highlighting some user projects in Deepnote while talking about some of the fundamental concepts of machine learning in general. So I am not a professional by any means, but I'm joined by Jakob, who can kind of help me through some of the machine learning side of things. And I have some common questions that I naturally come up when I look at projects like this and data sets like this. So I'm hoping that I can bounce some of those off of you and we can kind of get a feel for it and then maybe do some live coding after we're done with that. So
Perfect.
our ultimate goal here today is kind of to highlight how we can first address a new data set and start looking at it and then kind of break it down from there. So those are the kind of questions that we're looking to answer. So the notebook that I have up here on the screen now was a community notebook done by Abid on our community forum. He submitted it on our forum, and it was to predict the winner of NCAA women's basketball games. He also did a notebook for men's basketball games as well. So you can hop over to the community and check out both of those. These were both done with Kaggle data sets. So if you never used Kaggle, it's a good it's a good community to find different data sets and start working in machine learning. And it's also very very learner friendly, I would say. I guess there's a lot of public notebooks on each data set that you can really get started in working with the different data. Even though it's very learner friendly and there's a lot of sample competitions, and we're going to look at a sample data set and actually do some live coding a little bit later, it can at times be intimidating to open a new data set and really start breaking down that data. So one of the things that I wanted to do is kind of walk through his project a little bit. We're not going to go line by line, and I'm going to come up with maybe some common questions that I get when I look at a data set, and we can kind of go from there. So the first thing that he did in this notebook, I don't think he used any outside data sets. He did use outside data sets for the men's basketball data set, but not this. I think this was all contained inside of Kaggle. So when you first jump into a data set, it can be a little intimidating, especially one like this where there's a lot of different CSVs and variables and all kinds of things in there. Jakob, do you have a first kind of thing that you go to when you're looking at a new data set or a new machine learning project? It doesn't necessarily have to be a Kaggle competition, just when you jump into a project in general.
So the first thing that comes to my mind is exploring the data, right? So usually in Kaggle, the data is somehow pre-processed. At least the challenges that I attended were kind of pre-processed data. So heavy cleaning was not really necessary. In real world, a lot of heavy cleaning is quite needed to work with the data later. So, looking at the data, visualizing outliers, crunching some of the stuff, removing unnecessary things. And this is like the first thing, like first. Then before feeding the data into any kind of model, you need to balance it. Maybe you need to augment it. If it's image data, you can augment it in many different ways. But that's maybe more complex thing. But just looking at the data, having a clear view of what I'm playing with, that's the first thing that we want to do.
Sure. What about if you don't totally understand the subject at hand, like something like this data set where it's talking about NCAA women's basketball? How much time do you have to invest in the beginning just to understand the topic in general?
Okay, this is a great question. One of my students recently asked me this. So in my PhD, I work a lot with medical imaging data, and this is a perfect example that, it's probably very good if you understand all the details about that particular disease or condition that you are looking into in your medical imaging data. For example, some musculoskeletal problems in your bones and in your muscles. People and medicine students, they study it for years, so they can understand it deeply from the physical level up to some cases with different patients of different groups of age and ethnicity and everything. And so there is no way that me as a machine learning person would be able to match the knowledge of medical professionals. But the more the more insights that I have, the more I can then leverage in my work. So, but in this particular case, in basketball, I think it's good to at least have some basic knowledge about what's inside the data, what's the thing that we want to be predicting,
Sure.
maybe how is it being done in regular world, right?
Yeah.
So sometimes the predictions are done based on some data, but maybe in our processing we will see that also some other parts of the data are somehow they can tell something about what's going to happen. But yeah, well, the basics is the first thing. So you need to understand the basics.
Sure. That makes total sense. And that's something that it kind of intimidates me from coming into different projects just as an intermediate or a beginner in machine learning or programming or whatever it is just the overwhelming of trying to understand the data and the programming side of it, but also to try and understand enough about the subject at hand as well. So jumping into this notebook, we're going to look at some of the things he did in this notebook and some different things. He eventually gets to doing some using a program called Cat Boost. Have you ever used that library?
Yep.
So that's essentially what our end path is. But most of this notebook and the meat of it is in feature engineering in general. So I wanted to kind of start here and just talk a little bit about the different data and the way he went about preparing it. So there's a lot of different CSVs, and I'm not going to break down everything he did here because you can go through the notebook. But one of the things that he did was originally start organizing by teams and then start putting features in that he eventually wants to test on the program itself. So what he's doing here is he's organizing by team and by season. So it was originally just a full CSV of different seeds in the specific tournament over different years. So each year they have a different seed. Now, once he has that kind of data put together, then he can start grabbing other CSVs. And those other CSVs have individual stats about the season itself. So again, some understanding here of what he was trying to predict and what data he had to base those predictions on. And they're all in different CSVs, and he's going through and kind of putting it together as he goes. So eventually here, what he comes up with is basically a line that he has of the season results. So he can see how many wins a team has, how many losses a team has, and individual items like that. Then once he has that, he's kind of aggregating that data and summing it up so he can get those individual wins and individual losses for the season. Which kind of starts to bring me to my next question for you. When I think about beginners or intermediate or kind of anyone getting into machine learning, I'll stop kind of differentiating between the two. Anyone kind of getting into machine learning, my immediate thought is if I have a good algorithm or I have something good like that, wouldn't my model figure out what kind of data I need? Why do I need to change or remove certain items from my data? So if I'm looking at a data set, in this case, why should I ever decide a column isn't worth putting into the model, I guess?
That's a good question that can be answered in very long time, but I will try to shorten it. So the thing is that, like historically, we didn't have deep neural networks. We didn't have all these architectures that can crunch like hundreds of thousands of data items, whether it's images or signals or whatever.
Sure.
When we didn't have this, the models were more sensitive to specific outliers or to overfitting in some way, and so on and so on. And the more or the better job that you did with the data, the easier it was for the model to train and fit to the right thing and be able to predict the right classes or clusters or whatever. And so this is true for everything, even now in the age of deep neural networks. But right now, some of the deep neural networks, if you have large enough data set, can do these decisions for you. So if you have ImageNet, if you have a data set of some small images where there is millions of examples,
sure,
and you want to classify them to 10 different classes, let's say, or 100 different classes, and you have the right architecture with reasonable regularization layers and everything, then you are able to leave this job to the network. But if you have smaller data set or if you have simpler architecture, the better job you do, the easier it is for the model to fit.
Sure. Okay, that makes sense. So especially in a case like this where we're talking about a couple seasons, not a couple seasons, you're talking about 20 plus seasons, but still it's a relatively small data set. You're essentially saying it could lead to
Yeah.
overfitting or something like that. If I'm throwing in a column that I know doesn't really pertain to the outcome, maybe the network might learn something just based on that smaller data set.
So first of all, if we know, if our domain knowledge of basketball in this case,
Yep.
if based on that we know that some of the columns really doesn't make sense
Yep.
in any way, or we don't want it to make sense towards the final prediction, then we can just scratch it. It will be easier, it will be less data, less mess for the model. But if we are not sure, sometimes some correlations might arise. But so in this particular, what are we removing?
So
What are we removing,
in
Jake?
this case, he's actually kind of doing the opposite. They're all kind of separate data sets, and he's finding different features that he's putting into his final test. So the first thing that he's adding to the prediction algorithm is he's taking the entire season's wins and summing them up for a team. And then he's taking the entire team's losses for the season and summing those up for the team as well. So that's kind of how he's building it right now, and specifically leaving stuff in or out of those kind of calculations. So that was where I was kind of coming up with why not just throw it all in there at once. Hey, Alan, thanks for joining us.
Oh yeah, hey. In this case, it might not be that big of a deal. What's the size of the data set? There are heads. There is no info. I will. Can I? Yeah, I just have execute access. Can you give me edit, please?
You can have whatever you want. Let's go. That changed.
Do you have anything to add, Alan? Do you have any experience with basketball or
Are you a
choosing
basketball
the
fan?
right figures? Oh yeah, Alan is not hearing us right now. Maybe
He's still getting
Sorry,
set up.
I was getting set up. Hey, no,
It's
I
okay.
don't have any. I don't have anything to add. That was a good description. I heard most of it. You were talking you were talking about the trade-offs, right, between keeping a lot of data and getting rid of data, and how that affects the balance point of everything, overfitting versus not having enough data. Yeah, it's a big issue.
Yeah.
But you described it very nicely.
I have to rerun everything, so maybe we can continue with your analysis, Jake.
Yep.
So the thing is, just to very quickly sum up, if this was, if we had like tens of thousands, just making the number up, but from my experience, if this would be like tens of thousands or maybe even thousands of samples in the data set, then it maybe wouldn't make much of a difference. And usually in like in basketball leagues like this, how many teams there are, or how many teams are in NCAA women's?
A lot.
But why? But it's like 30, right? Or 20 or 30 teams. It's not like hundreds, right?
Right. In this case, how many make the tournament? Yeah, it'd be a controlled number, whether that's 30 something or 60 or whatever it is. So yeah, definitely a manageable amount.
Yeah. So I think for now, but we can say this data set is quite small. So
yeah, it's definitely small.
Any optimization, any optimization on data level is a good thing to do. And even in general, like even if you have large architectures and large data sets, the better job that you do with the data, it's always a good thing.
Okay, perfect. Awesome. So that kind of answers my first question when we're selecting kind of items from the data set, what to add and what not to add. So again, something that he's going through and doing right now is adding features that he thinks are going to be useful to the prediction of your final kind of goal here. The next spot that we get into is something that I think is really interesting with feature engineering, and that's actually modifying and changing the data that you have in some way. So one thing he does is compare the difference in a win. So comparing the winning team's score to the losing team's score during the season to see how many wins are over a certain amount. So you'll see here in this cell that I'm kind of showing, he ends up creating a new kind of feature for the data set itself called gap wins. And I think that's like I said, maybe just the difference. Yeah, just the difference in the score gaps in the winning games. And then he does something very similar with the losing games as well. So he's taking all the losing scores and summing those up and seeing what the difference is there to create his own features. And again, this immediately, just a beginner thought that comes up to me is if you have those features, in there already, wouldn't your model figure that out? Or again, are you just trying to get to just because you have a smaller set, you're trying to simplify it for the model, so you know that that's going to be a important statistic, so you're kind of doing the work ahead of time to present it to the model?
Yeah, so in this case, if you are sure that you know how to calculate some better insight from the data using a formula that you know that works because of reasons, historical reasons, or because it's proved or something like that, then the formula is usually, most of the time, is easier than waiting for the model to figure it out. In this case, we could employ some interpretable model in parallel and train it and try to extract the internal information and see if the same formula is somehow represented in there.
Right.
And we would see that that some kind of the knowledge was distilled in the model. Sure. But if you do it in advance, it's a good thing.
Okay. That makes sense. So he continues on, and we're just going to keep building this data out a little bit. And again, doing some cleaning. Like Jakob said, this data set's pretty easy to work with and fairly kind of handed to you a little bit. So there is some cleanup. You can see here he's filling in NA values, so values that don't exist in the data set. He's putting it in place with some type of other data set or with some type of other value. Is there a general rule that you go, if you have a data column that you really want to use in a data set, how do you decide between creating just like an irrelevant value? Say you have a average score lost or something like that, and you're missing a score for something. How would you approach that? Would you just throw in some sort of placeholder data, or do you kind of try and fill it with something meaningful to kind of your scenario?
I don't know if this is the best answer, but it also depends on the architecture that you use later.
The model itself.
But if you enter the mean of all the other values, if it's an integer, you don't mess it up. Or if you remove the whole sample, so if there are some missing values, you can remove the whole item. You also don't make that big of a problem. So it depends if the sample properties, if there is one column that is usually empty in your data set, but there is a lot of others that are valuable, then just put an average of other values into this one column wherever it's missing. If the sample is completely weird or completely broken, or it doesn't make sense, or if it's like mostly nulls or mostly zero values, then you can just remove it.
Right. Okay, that makes sense.
Maybe so there are other techniques depending on the data. If this is images or particularly if you are doing prediction of integers or just small classification, or if it's much larger task. But in this case, using average is something that I would do.
Sure. Yeah, so case dependent, depending on what your task at hand is, what the model is. It's hard. I know it's hard to give a generic answer to a question like that when you're talking about certain data sets and things like that. But again, what he did in this case, I think he ended up filling it just with zeros, maybe, or yeah. I think he was just filling it with zeros. But again, so just kind of a thought on what's happening here. So again, then eventually we get down to the end, and he's going to try and put together a training set of data here using the features that he engineered from the data set. So he's using some features that he created himself with a win ratio and different things like that towards the end, and some that were built into the actual data set itself, and then eventually training on that data. And one thing that I thought was kind of interesting about this was the ability to kind of do it all within Deepnote, to kind of investigate the data, look through it, analyze it, and kind of go from there. So that's kind of what I wanted to lead into for kind of a task that I thought maybe the three of us could play around with a little bit in kind of the next section, where we're actually taking a look at a data set and going through it. But any other comments on this data set or this project? Eventually he goes down and he does do some cat boosting. I don't know a whole lot about that model. Maybe one of the two of you could tell me a little bit more about it. I know it's a form of gradient that it's training this model on to make a prediction. It looks super easy out of the box to plug and play and kind of get some decent results with a data set. Is this something that you could use early on, even if it's not your end model, to kind of start highlighting what features are useful and things like that?
Yeah, in tasks like this, definitely you can try initial training and see what's happening.
Yeah.
But there are comments from King ABZ Pro that removing reduces performance and adding means that reduces performance. Yes, that's true. But if you remove the whole whole sample, whole one item,
Sure,
because of one value, but there is 10 different other values that you can use, then you are not losing the performance, because there is still some information in the other columns in the other properties. But if this is just a single thing, yes, you are reducing the performance. So this is just trade-offs. You need to make some decisions, and if you want cleaner data, you can have a little bit cleaner data, and so on and so on. Also, very good observation. Cat Boost is one of the best models for tabular data. Actually, do you want to hop on the call and talk us a little bit more about it, Mr. King?
Yeah, feel free if you'd like to.
Yeah. Let us know if you are up to joining. We would be happy to talk.
I'd love to hear more about Cat Boost, actually.
Here is the link.
I'm not familiar with it.
For the Zoom, and also that Talks Mango is saying hi. So hi, Beck.
Hi. So, the ones that I hear about all the time, just from the outside of the data science community, is Cat Boost, and is there like an XG Boost, something along those lines? Are those all versions of kind of the same models that are just kind of competitors that you're choosing between what library you're using, or are they totally separate algorithms, I guess is my question.
So I don't know how far to go, but basically they have the same basis.
Sure.
But a little bit different tricks. There'll be different tricks that make it work. Yeah. Basically, it starts with decision trees. Then from decision trees, you can build random forest models. And yeah, and adding more and more years of research or
Sure.
tips and tricks, and you get the optimized XGBoost or
more and
Live
more.
GBM or Cat Boost or hi, Mr. King. Maybe you can shed some light on your experience with
Wait, I have.
boosted trees algorithms.
Hi. Hi.
Are you Abid?
Uh, can you hear me?
Not very well. Maybe if you put your microphone a little bit closer,
Can you hear
or
me now?
Better.
yeah, it's better, but it could be even better if you make it louder or closer.
Wait, audio settings. I usually do this on Discord. I'm new to.
No problem, man.
New to
But
Zoom.
I think we can hear you quite okay now.
Okay.
So,
Can you hear me now?
Way better.
Yeah. Actually, I was here because I promised someone on the forum at the community.
yep.
Sure.
Yeah.
Thanks for stopping by. We appreciate it.
And you guys are talking about my notebook, actually.
Yeah. Oh, okay. So you are a bit, yeah.
Yeah, yeah.
So why did you choose Cat Boost, and why is it the best thing for tabular data?
I choose many. Like I started with linear regression, logistic regression,
Mm-hmm.
and sklearn. Then I choose many. Like there were SGD classifiers. There were many classifiers because we have to predict the probability. So when you come to the competitiveness, you always choose the best of the best. So right now in tabular data, the best performing are XGB, like simple gradient boosting. Then there is gap boosting. Then there comes light gradient boosting, LGB, which is Microsoft. One is Yandex, the Russian one. The cat boost is from Yandex, the search engine, the Russian.
Yeah. Mm-hmm.
And the Microsoft one is LGBM. They are all like publicly available. You don't have, you, they just they just created it. And XGB is, I think it's not affiliated with anyone, but it was the original gradient boosting that was like quite famous back then. Like 2 years ago, people use this. Even in when you are using R, people always use the XGB because it performs quite well if you hyperparameter, like you change the parameters and you there are so many things you can do. And you can use Optima. There's a library called Optima which can automatically uh, adjust your parameters so your model perform better. So in this case, uh, we have very limited data, we have very scattered data, and the team's ratings, team performance depends on year basis. Like let's suppose there was some anomalies too, like in year 2017 something happened, and the whole data that predicted, like it doesn't predict that well for 2017, but it predict really well for rest of them. So there are some anomalies, we cannot predict everything. And even though we had like 1 year gap because of corona, the new games that are happening now, I think right now there are some games of uh, going right now. They For men, it's quite unpredictable, but for women, it is quite predictable, and people are getting quite good score of that by just using ensemble of what can you say by ensembling XGB boost, light light XGB and cat boosting, and they and they use weightage ensembling like voting classifier. So you check which model perform well, and then you give the weight, and then you ensemble it and get the data, the final data. I hope you guys are understanding. I'm not.
Yeah. Yeah. Sorry, I kind of forgot that you actually have all of this in the notebook. I just didn't remember and I didn't scroll down. And yeah, you really have the so yeah, and, we can see down below that you started with logistic regression and then went on to LGBM and yeah, and the cat
Yeah,
boosting and
I experimented with so many things. Like you can just change the method, the model, and it will just run it for you. You don't have to do anything. Just
yeah,
change
yeah,
the.
yeah. Yeah. I'm just trying to do it in my fork. It's just it would be this is not a critique, it's just I will try to maybe run everything in parallel or afterwards so we can see all the dashboard next to each other, so we have the history of all the things. We can even use weights and biases for visualizing the training or just the
Yeah.
results, and then we can compare all the models and we just see it on the nice one plot. But yeah, it's everything there, so that's quite a good job, so thanks for that.
Well, in competition, you just try to give one like solution. I can test. I have
Yeah.
notebook, but I wanted to get like the best of the best. So in my case, in like after there was a gap between two competition. First was of men, then women have was on Sunday. So they had like 2 days left. So within 2 days, I realized that LGB, like light gradient boosting, was performing well, but with hyper parameter optimization, like you can do with Optimum.
Yeah.
So
Oh, so you use Optim for everything?
no, not for because Cat Boost doesn't have Optima. So you can for cat boosting you can use that. Uh, it have built-in function. I forgot for hyperparameter. It let me check cat
So,
boosting.
well, we can just use some grid search to find the best values and train
Yeah.
it several times
It
afterwards.
have inbuilt
And
it have inbuilt function for grid search. It will do on its own. You just need to type.
Sure.
Wait, let me check documentations
That's
because
cool
I
though.
can't remember.
And again, for like beginners though, it's nice to kind of hear that the right answer isn't picking the model. The right answer is finding the model that kind of fits the problem or fits your solution. So not to rule anything out, I
Yes.
guess.
Yes.
yeah,
You have to always start from zero, like logistic regression, logistic model, sklearn basic. Even if you can find the answer using x, like y is equal to x mx plus c, like you just need to get the result by even very simple way. Like there was a NLP competition going on. People just swap the data and try to make the label accurate by just looking at data, not using
Sure.
any model.
Sure.
And most of them got really good score. So I'm just saying sometimes simple solution works really well, and the more neural network and you go into deep into the
yeah,
tens.
of course, of course. Well, if you don't have large data set, and even more if the data is reasonably shaped and like it's numbers or floats or something like that, then it's more simple to train something simpler. By the way, I shared the grid search parameter in CatBoost into the chat in Twitch. So yeah, we can just add the grid search directly to the CatBoost parameter. But yeah, if I have some time after this stream, I will try to connect it to some dashboard and see all the whole space of the hyperparameters to
That'd be cool.
see basically what works.
Awesome.
You,
Well,
you,
thank
Abid,
you.
by the way, in this,
yeah. I have one more suggestion. If
Yeah.
you want to use, like, if you don't want to do anything, like, there is a library called AutoML jar. You just need to put X. You just need to put the parameters, and you just tell the time, how much time you want it to train, and it will do all the job, all the dashboard, uh, all the display. It will do everything. Just few 3 lines for 3 lines. It will do
what's the name of it? AutoML what?
AutoML jar.
Jar.
AutoML jar.
Yeah.
Just go GitHub. Go to the GitHub. It will show you AutoML jar.
Thanks. I didn't know this.
It
Thanks
will
for
do
the
everything for you. You don't have to do anything.
cool.
And it got me a really good score in one of the companies. But you still need to put effort in feature engineering and data cleaning and so many things.
Yeah,
Sure.
that's always a good thing, though.
It this is really good because it have golden features, and it also have weightage ensemble. It also have, it do all the work for you. You don't have to even worry for anything.
Nice. Yeah. Okay. So thanks for the insights and everything.
And thank you for submitting the project as well. If you want to hang around, we're going to talk about a couple other things on the stream and maybe break down some data as well, just to kind of get everyone's insight and start looking at stuff.
Yeah, I'll stick around for a few minutes, and then I have to. I told you I will just come for the chat, and yeah, okay.
No, I appreciate that. And thank you for talking about the project as well.
Yeah. Okay.
By the way, we have the competition.
Yes.
So, yeah. Do you wanna mention it, Jake?
Yeah, let's talk about that a little bit. So with this user submission, which was a great submission and highlighted some machine learning and data science and different things in the submission itself, we actually have a competition that's coming up for the month of April, I believe. Yes, so it closes on April 30th, and it has a grand prize of $1,000 and swag for the top 3 finalists. So essentially what we're looking for is something not similar to what Abid did, but something along those lines in data science or machine learning, or even explaining libraries, anything that you're doing in Deepnote to kind of showcase the capabilities in data science and machine learning in there. So how you kind of can go about this competition, you can create a notebook fairly simply from Deepnote. You can sign up for Deepnote, create a new project, and then start filling out your notebook just like you would any other Jupyter environment, and run it from there. Once you have it kind of finished and polished and that sort of thing, there is also a publish icon down here towards the bottom, which I won't do, but it's not my work. But you can publish your notebook as well, and then sign up for the competition from there. We shared the competition link in the chat as well, so you can see it there. Anything else, Jakob, that I missed from that? There's also some examples if you want to look down of some other notebooks here that people have submitted in the past to kind of get inspiration from.
I have a question.
This is it. Yeah.
Sorry, just a quick question. But does it have to involve machine learning, or could it involve just analysis, visualization, more generally?
Yeah, it doesn't have to be machine learning. Just has to be remotely related to something data science. So data explorations, visualizations, some crunching, crawling, maybe machine learning, but not necessarily. Just whatever you would do in Deepnote. Besides these generic data science topics, we have a bunch of users doing like chemistry engineering and like some particle optimization stuff. So basically whatever you would do in Deepnote.
Okay, thanks for clarifying.
So if you look through some of these
Yeah.
sample notebooks, here's one that's just one that they threw out there. It was is this a GAN network or something that they're creating? Some type of network, just again, showcasing something in data science done in Deepnote, and then sharing that with the community.
Oh yeah. This is a style gun from Tejas. It was pretty popular on this Russian open data science forum
That
on
is
Slack.
awesome.
Everybody was liking it. But yeah, so
That's
this is
amazing.
existing pre-trained style GAN, but yeah, I mean, the more original the work is, the better. But you can
Sure.
definitely use some pre-trained weights or something like that.
Awesome. Any questions on that?
Awesome.
Let us know in the chat and we'll help you out and kind of give it a better breakdown. But definitely get some feedback from the users. We'll be around in the community as well. If anybody has any questions or issues or comments, concerns, wants feedback, whatever it is, go ahead and share it there and we'll help where we can. Cool.
Yep.
So we've talked about some different things for a while. I created a notebook that I think we've shared in the chat, and this is using another Kaggle data set. It's a very simplistic data set and one that they use to kind of teach and do different learning with on there as well. I thought maybe we could crack it open and see if we can do some visualizations and maybe kind of break down the data, just how you guys would in a new data set for yourself. So the data set is the Titanic data set. It has a test and a trained CSV, and that's really it. And inside that CSV, I guess I could actually pull it in here. I'll pull it into the notebook. It just has some fields and some different information. The training data set, you're using the prediction to predict whether a passenger on the Titanic survived or did not survive the tragic event itself. So I'm going to pull in this notebook and we can start pulling it in here. Just one second. I have a lot of windows open. That's a good point. It is a playground competition. People still are trying to get the best score in this project. And actually, I think the project leaderboard is reset every so many months as well. So if you're new, it's not always flooded with the same scores or things like that. Okay, so now we'll start pulling the data set in here. So again, if we're just looking at a fresh data set, I guess what is your guys' go-to for kind of starting to figure out some correlation if you don't necessarily know the data set too in depth? Do you immediately try to create visualizations between your target parameter? So here in this notebook, our target parameter is this second column that survived, either a 0 or a 1. And then we have our columns kind of flowing from there. So something that I do a lot of times is to kind of create almost like a pivot table or something like that, where I can see if a column correlates with your actual target parameter. I'm sure you guys do some visualizations probably as well to see kind of how things compare.
I will just point out one Deepnote feature
Yeah.
that when you look at the like above the table, below the code in the data frame visualization, you see some interesting things. So you can see the distribution or kind
Ooh,
of
yeah.
histogram. And also you can see some outliers in the sex. You know, you already see the share between male and female sex. Yeah, and so on. The name is not that helpful because all the names are different, but you know, you can see that all of them are 0.1%. But basically, yeah. So this is the first thing that you can look for. In H, you already see that there is a nan in row 888, and yeah, so basically this is something to sell some Deepnote features, but maybe Alan can have some more insight on actual knowledge.
So right away, you're looking at generic column structure. So even before, I might have got kind of ahead of myself, even before you're looking for correlations or anything like that, you're looking to try and figure out kind of what the data is itself, like how many males versus how many females. Is there any kind of bias there? What about how many survived versus didn't survive, that sort of thing? So you're looking at it kind of generically before you ever even tap into any correlation or anything like that.
Yeah, I think those are really good suggestions, and I really like that feature in Deepnote actually, that you can get a sense of the outliers and the distributions right away just by having the data frame sort of right there in front of you. That's really, really nice. Yeah, I mean, like, I think all the data cleaning things that people would do would apply. There's a nice method in pandas called describe, which I use a lot. You can just go df.describe, open close, and it will tell you the min, the max, the standard deviation, the counts for every single column. And that's a nice quick way of just beginning to see what, because you can't eyeball everything. So it's a nice way of doing it. And yeah, certainly looking at correlations is a nice way of getting some actual statistical values as well. Yeah, if you do df.describe, it can be nice. Which is good if there are some values that are so extreme that you may not want them. And you can see the quantiles and everything. It's also very helpful.
Sure, that makes sense. Awesome. So one thing that
I think
go ahead.
Oh, sorry, I was just going to say, because I hopped on a few minutes late, and I might not understand fully what's going on here, and maybe you guys could clarify, but I think there's also some relevance too in terms of like the ratio to ones and zeros, right? Like if it's unbalanced, if it's quite unbalanced, that might be something nice to know. That's true, right, Jakob? Like,
Yeah,
totally.
totally.
If you're trying to predict and you have mostly zeros, then that's going to affect the algorithms that you might choose later on.
Yeah. So first of all, normalizing the values, and second of all, also balancing.
Yeah.
Okay. So with our data set here, how could we go about seeing how balanced our data is? Would you?
Well, you could sum the ones, for example, and compare that to the length of the data frame, something along those lines.
Sure.
And I don't know that there's any rule necessarily, and Jakob would probably have better heuristics, but I just from my understanding, you don't want it to be imbalanced in a perfect world.
Sure, you might start overfitting towards one or the other just because it's so skewed one way or the other.
Well, I think it has something to do with I only have a surface level understanding, but conceptually it has something to do with the fact that you don't have enough evidence to make the prediction in one direction, right? So it's kind of like you'll end up just predicting things to be zero if that's all you have evidence for. Something along those lines, although you can correct me if I'm wrong.
Yeah. Well,
Right.
for example, if you have like, okay, this is not a good example, but I will say it anyway. So if you have like thousands of patients without the tumor, and then you have 5 of them with the tumor in the head, and then you have 1,005 samples in your data set, then obviously you will train the model to predict 1,000 to 5 healthy to unhealthy. So if you balance this is very simplified version because the zero value is not really the same as like balancing, but yeah, I think this illustrates it quite well. That, but even, I mean, in this case, we can even try it. We can go ahead and try to work with the data unbalanced and see what happens. But I mean, we can do the better solution, and then later we can just unbalance it and and see
so,
how the results change.
So if it was something like this where you're talking 300 something survived versus 500 something, would you consider that close enough for most models that you wouldn't worry about balancing, or do you still want it to be kind of one for one sort of thing?
So what do we want to predict right now?
Whether
Or
someone...
what's our task?
So the task at hand is to predict whether someone survived or did not survive on the Titanic trip itself.
Okay, so it's, yeah, but we have the data for all of them, but we will split it to somehow omit the values that we know, right?
Yeah, so you have a training set. So in our data set, we have a training set along with a test set.
Yeah, okay. So,
but we, if we're not going to submit or anything like that, we could split up the training set so we have a validation set, something like that.
Yeah, I think we could go ahead and try to continue with the split as we have it, but I would do something to even it out a bit.
Sure. Yeah, I was, and even not necessarily in this stream, I just kind of meant generically, you would still look to clean it up to some degree if you were doing this on a real world problem. Just the only reason I asked was just because naturally to me, it looks close. So I would think, oh, it's probably close enough. I was just curious what a pro would do.
It is. I mean, it is. Yes, it is close enough. It is close enough. Also, sometimes in some cases, very particular ones, the split of the data set actually represents some underlying knowledge of the world, and there is a reason why there is more of something than something else.
Sure.
So if that should be part of the reasons for prediction, then you can also work with it. But in this case, I would. But we can go ahead and do what you wanted to do. So
okay, that makes sense.
Yeah, nice. We have correlation metrics. Nice.
Yeah. So again, when I'm looking at it, and I'm a beginner, so you guys can correct me as I kind of go through it, but I'm starting to look at stuff and really understand what the data set's about. In something simplistic like this, you can immediately maybe gain your own kind of knowledge of how you think you could naturally start to predict if someone survived or didn't survive on this particular disaster. One of those that I immediately think of is age, sex, and maybe your class, so where you are in the ship, that sort of thing. So one thing that I do, I'm not I tend to draw more like pivot tables, like Excel sort of stuff than graphics. But so one thing that I do is to try and create some type of almost a pivot table to see how much a field will correlate with the target I'm looking at. So like in this case, in this cell that I did here, I'm showing the survival rate of a female versus a male. That's it. Just to see how much that, again, that feature or that column of data kind of correlates to our eventual answer. So that's kind of how I would start breaking it down, is breaking down the individual pieces of data and kind of seeing what correlates and what doesn't correlate to my eventual solution, I guess.
But one comment to the survival rate to women versus men.
Yeah.
Can you also plot women versus men in the whole data set? I mean, not just the survived ones, but all of them. You know what I mean?
Sure. Yeah, I see what you're saying.
So then we will see just
Oh.
this, and
Yeah, that.
so if we. Oh no, sorry. I want to do. Are you in the same cell as I am, or? Oh yeah, you are up there. Sorry.
Yeah.
Okay, sorry. I was totally somewhere else. I was plotting stuff down
Oh, that's
below.
okay. I'm with you now.
So blah blah blah. So if we do, or we can do it like this. We can do it for. Oh yeah, but survive is 0 and 1. Okay, kind of. Okay, so there is the mean, so it's also represented in there.
Yeah, so it's representing both.
Yeah, so it's mean. Sorry, I was. Yeah. Okay. We can go on. This is interesting.
Can you guys talk to me a little bit about the correlation matrix in general? So we see the perfect correlation down the diagonal, obviously, when it's comparing the column to itself. So what you guys are looking for in this case is trying to look at the survived column compared to other columns above to see how well those correlate. Is that what you're?
It might be. I tend to look at the not. That's fine. I tend to also look at the things that are correlated together because they might account for the same variance, and so it might be a sort of redundant feature to keep in the data. So that's something that I think about sometimes, because as far as I understand, you want the features to be independent as possible, if I understand it correctly. And if they account for the same variance, then you may not need to have one of them in there. That's how I think of it.
So if something is too similar, you're wanting to eliminate one of those columns.
Well, potentially.
Right. Okay. And then sort of the same thing below, another. So something that we know, I was just curious. Is this, oh, but I'm missing some of the, why are we missing some of like the classes like sex and
maybe their data types are
different?
not quantitative. Yeah, they might be objects. So I mean that's actually a good point, and it's basic, but going back to the data cleaning, it's nice to know the data types too, which you can use df.dtypes for. And in case you're expecting something to be a numerical, but it's actually represented as a string or an object, then you might need to convert it.
Sure. Okay.
Even if it cannot be converted to numerical, like male or female, you can do is male 0, 1, and is female 01, and then it will be also better to work with. Not necessarily if we don't need it, but sometimes it can help.
Okay, that makes sense. And then from there, we can actually break down kind of what we need for the features itself.
Yeah, see sex as object.
Oh, okay.
Yep. So I don't know how it's actually represented, but I'm sure if you wanted to convert that to a number, we could.
And for this,
Oh,
probably.
I see. Oh, it's actually strings. Okay, yeah, I see. Yep.
And for something like this, just for the confusion matrix or something like that, we don't really need to convert it for that. We know it correlates, right, from kind of the table that we had above that. Just if we look at the mean value of the male and the female, does that show us there that, you know, if there's a 0 for a survivor or a 0 for someone who didn't survive and a 1 for someone that survives it, does that show enough correlation that we need to include it in our final model from that, or would we need to dig deeper into that column itself?
Are you asking whether or not sex should be included in as a predictor?
Yeah, like as you're digging into the data set, is you know, when you hit a column like that you see that to me, just at the immediate looking at it, just printing out the values and seeing how that mean affects who survived and who didn't survive, it shows a correlation to me. Is there something that I'm missing where I should clarify that more, or am I not seeing, or is that enough that you want to try to include it somehow in your model?
I would say, I mean, unless you guys have a different thought, I don't think that it hurts at this stage to keep it in the model.
Yeah,
because it does look like it distinguishes survivability very well. But again, I think that it probably depends on all the magic that goes on behind the scenes with the algorithms in terms of whether or not that's actually needed or not, and whether it accounts for some kind of unique variance. And it may be the most important predictor, and it may be not the most important predictor, and there's trade-offs with having it in versus taking it out. But I mean, at this stage, I can't see why leaving it in would be a problem.
Yeah. Yep, makes sense. Okay, so as we go through this, and if you're looking to do something like Cat Boost or something kind of out of the box, it's fairly easy to get things set up. So once you start mapping out how your features correlate or what you have in front of you, you can start adding things to your eventual data set that you want to train on. So one thing that I did and that Abid did in his data sets as well is start to kind of pick out different features that you want to include. With my data set, I started picking out just the features that correlated to me, or the features that made sense to add to the model. That was the class that you have, your ticket class, the sex of the passenger, male or female. The age kind of made sense, but there was some null values in there as well. So we might have to do something with that data. And then it ended up, which didn't immediately showcase itself to me, was that you also was that embarked, where you got on the ship seemed to correlate to your survival rate as well. So one thing, then once I kind of had my features here, then we can start narrowing down our data set. So if we look at just our features, I do that all the time, forget to run my cells. So if we start looking at just our features, again, we can see in our nice printout here from Deepnote as well of some different concerns with our values. I think the red is showing me that there's features missing on those, probably. Is that what I'm looking at? 2 others are missing. Do features.
Yeah. There was an and, so that was right. By the way, Abid has some good comments in the Twitch chat, so I will add him as editor in this notebook.
Yeah.
He might do some editing if he wants, of course.
Yes, if you want, feel free to jump in and change anything or shaping the training, which feature. Oh, I think you did that. I think he used the shape to show which feature had the most impact in maybe the NCAA, the men's basketball one that we didn't look at. So that is interesting. So again, maybe if you're unsure of features, I think what Abid is suggesting is you might be able to push it through the model and then check the shape afterwards to see what had the most impact on your final answers. Where can I see, where's my total for our training? For our 891 records. So if we look at our some of our data cleanup, so now if we've kind of highlighted what we're correlating here and what we're looking at, and again, we're trying to kind of get through a couple things here, so we're speeding over some of it, but once you kind of have that and you start looking at the features that you want to use, we can also start looking at what's missing from our data as well. So if we sum up the columns that we at least thought we wanted to use in our final model, you can see that we are missing a lot of values for our age. So again, we're talking 177 out of 900 or so rows. Does that warrant enough to drop that from the data set, or is that a hard question to answer as well? Is it something that we should put an average in there, or a 0 so the model knows we don't know the age, or a negative number, something that wouldn't occur, I guess? My thought again is that I would kind of shy away from using an age that might be real to the model. So when I look at this and think about it just from a beginner standpoint, my immediate gut reaction is if I want to use age in my model, I should give it some value that the model will know that it's not a real age, like a negative number or something that wouldn't naturally occur, I guess. The other beginner thought I would have is like to get a mean and give it something that's kind of right in the middle. So, those are my 2 thoughts. Is there anything anywhere else that I should be looking, or do those not make sense?
Mean or median, but if you do like a minus 500 or something like that,
Yeah.
Then you can confuse the model as well with this.
Sure.
Maybe, yeah, well, even in this case, I think. But, I mean, safe here is to drop it. Yes, we lose some data, but we can compare the reason. I think we can still, we have time to do both. So let's drop them, or let's not drop. Yeah, let's drop them. I would let's drop the nans in the age. So the whole rows, and then I would see what we can do from cat boost, and or like GBM or whatever you wanted to use, and then we can do the same with the actual. Yeah, or you can do randoms, of course.
Okay. Yeah. I see.
This is a great comment that even that if you use mean, you can randomize the mean and spread the mean value around. So together it's mean, but it's not always the same number itself. So this is also something that prevents overfitting.
Okay.
If you have a lot of exact same values, then the model can
makes sense.
So how do we, is it just df, would it just be df features dot drop? Is there a drop NA for if we're wanting to drop just the rows?
Yeah, I think the default is row wise. If you, uh, are you trying to drop a specific? If there's a nan in a specific column, you want to drop it, or
Or do we want to just drop any nan?
I think if you just say df.drop na, it will drop. I think it will drop any row that has a nan in it, which may not be what you want if there's certain columns that have nans in it that you're fine with. So you can say subset equals and put a list of columns in it you want it to consider, and then it will drop those rows only if those subset of columns has a nan in it. So, for example, like if you have your your 4 or 5 features, and those are the features that you want, and those go into the model, then you could add those as a subset so that it's just like, hey, as long as those don't have nans in them, that's what we want. As long as the model's only going to see that.
So 712 rows, if we drop the all nulls, it's, simple. We can go for, I think we can pick this up and just take this and go.
Okay.
Okay.
So you think take the whole feature set. Do something like that?
It's just below that already.
Oh, geez. Yeah, sorry.
So exactly. Yeah.
Oh, I'm sorry. That's not going to work in place though, right? So you'd have to reassign it.
Yeah.
So, yeah. Nice.
There you go.
And then did you want to did someone already do the male female binary thing? Because there's an example of how to convert it to ones and zeros if that's helpful, or maybe the algorithm doesn't care. I'm not really sure. But
I think in Cat Boost we can do it. I think we can leave it as is. I think we have to tell it what features, which ones are categories.
Okay, great. Great.
I'm just doing some quick imports here.
I'm really pumped about this Deepnote competition, by the way.
You got any ideas
so
you want
cool.
to share with us?
As soon as you said, well, it's so funny because like as soon as you said that, I was like, oh, I have. Well, I don't want to say it right now on the stream, but I'm not like it's going to be that great or anything. But I definitely have a project in mind that it's running parallel to something I have to do at work anyway, and it would be perfect. Give me extra inspiration to do it in Deepnote.
Looking forward.
Yeah, I'm so pumped about it.
Okay, I have a question for both of you.
Sure.
Would you be able to? I think you definitely will, but will you be able to finish this if I leave you right now? Because it's kind of getting close to midnight over here, and I just saw my to-do list for tomorrow.
No. I appreciate your time here and answering our questions or my questions, I guess. And thank you for joining us. Appreciate it.
Yeah, but I'm definitely looking forward to what do we come up with, and I will try to connect the Cat Boost to weights and biases later, and to see some nice dashboards for the hyperparameters. So good luck. Yeah, good luck with the finishing.
Hey, thank you.
So good to see you. Take it easy.
Bye.
So I just grabbed kind of the basic of a Cat Boost model. I'm just looking at the documentation a little bit and see if we can kind of crawl through it. Maybe Abed, if you're still here, you can help us along the way. We'll just try and see if we can get a prediction kind of set up just from our basic data set that we have here. We do need to define a model, and we're going to use and you can correct if there's a better one that I should be using or something like this. I'm taking this off of the documentation. So I'm grabbing our model, and Abid, feel free to correct me along anything I'm doing here as well. So essentially with the cat boost kind of generic model that I'm throwing out here, I'm trying to evaluate it on accuracy. I'm picking to use my best model. So I think that's as long as you're training through however many iterations you want to take, it's going to take whatever the best model you achieve in those iterations, and then use that for your test feature down the road. So again, that's kind of all I set up here, and this is kind of the basic setup for our cat model itself. The other thing we're going to have to do is we're going to have to look at our data set and see what our categorical classes are as well. So inside of our data set that we're actually the finalized data set that we're going to use, we have 1, 2, 3, 4. We have 4 different columns that we're going to use in our data set, and 3 of those are categories, right? Male, female. P class is a category as well, and embarked is a category, I would say, right?
Looks like it.
Yeah, P class again is an integer value, but it's a category to me, based on what category of ticket you have. So I would say our categorical columns would be 0, 1, and 3. So we'll go down to our, I had it set up here. So again, we're entering our data set here. We're going to use df clean for our data set. We haven't broken off our solutions. Let's see if we can grab just our y values. Can we grab just the survived column off of that, our original data set? Oh, but we dropped columns too.
Right. So you might want to, because they need to be the same size, right?
Yeah, we should have kept our. Let's just go back.
So where it says clean, where it says df clean, you could probably just, instead of features being the set of columns, you could have survived there as well. Drop all the nans and then split it into the predictors and the outcome.
Does it survive? What if we add that to our features?
Yeah, can do that.
Then we'll get our survived back. Then we're going to go ahead and drop everything out now. So we haven't split it off yet, right? So that... Oh, that's just our sum. Then we're actually getting our clean data. Hopefully this time, yeah. So this time we have our survived. So then if we wanted to break off our... Could I just do something like my y value is df underscore clean and then just survived?
Yep.
And then that should give us our y values, or our survived or not.
Yep.
So essentially all we did was we put back in our survived column because I left that out, and then we cleaned the data so they wouldn't line up anymore. So now they line up 1 for 1 with the amount of data we have. So we can go and... Did I not clean it? Why do I have 890? Oh no, that's good. Okay. So we have our df clean. So again, this is something that I made a knee-jerk reaction to how to kind of set it up. So if we want our training set, we don't have the answers to our test set. So in order to train our data, we're looking to see if we can break this up somehow to actually train our data. I took the first 800 rows of our data set to use in my training, and then the rest of it I was using as my validation set. You hear numbers thrown around a lot. I would say usually like but it depends on your data set. We don't have very many rows in general, so it's hard to break off much more than that, I would think. But again, something you can play around with.
Yeah, I think it's fine for example.
Yeah, for the but definitely something that you would want to kind of work through on your own. Let's see. Cat features must be an integer or string. Non-default.
You might want to look at 0, 1, and 3 again, those columns, just to make sure that they are what you think they are.
Ooh, yeah, that's a good idea. And that, because we didn't drop that column, did we? So the survived is still in there? So we could be cheating a little bit too. How can I, so our df underscore clean.
Yeah, let's take a look at it. Yeah, okay, yeah. So definitely want to say, I can try. Yeah, I think you can say like drop. What is it? Is it like drop in it? Is it like, I can't remember these things off by heart.
I know. I struggle with pandas too, trying to remember.
Is it like that? Okay. So, and then I'll just...
Does that do it in...
No. So is this okay before I run it?
Oh, absolutely.
You want a new data set? You want a new data set back without survived?
Yep.
Okay.
I think that's good, right?
You should be okay.
Yeah. And I just didn't want it to be... I didn't want us to be... obviously have the survive column in our data set would be an issue.
No, that would be horrible.
Okay. Oh, that's good. That we already dropped that. So, okay. So now let's try again. Labels variable.
Oh yeah, I think a bit is importing the built-in method for training to split your data into train and test, which is really, really great. Yeah, it's a nice way of doing it.
Thank you.
So what's going on now?
He is putting in to split off our training and our test set.
Yeah. Beautiful.
And then once we have that, then we can put that into our model. So our Y, yep, df clean, he's got it. And then take out my square brackets too that I had there. There you go. And then we'll do the same thing. So again, as we're looking at what Abid's doing here, you can see that he's breaking off our training set first into two variables, which he did by percentage. I think he took 20% of our data for validation and the rest for training. So he's inputting the X train, the Y train. Then we have our category features that we've labeled. And then after that, for our evaluation, he's going to put in our Y train and Y test. X test and Y test. I'm sorry.
Nice.
Look at that.
Thanks, Abid.
That's awesome. Appreciate it.
Awesome.
So a much better way of breaking up our data, and now we have our output from our algorithm itself from the cat boost algorithm itself. And you can see that as it goes through iterations, it's keeping our best model every time. So it found a better model here on iteration 20. And then if we keep going down, you can see it found another one on 81. So I'm assuming then it's going to save our best model in the model variable. So then we can do our prediction from there. So we can do that, I think, pretty easily. I think it's just a model.predict. And so we can say our predictions equals something like model.predict. And then we can pass in our other data set, which we didn't pull in that data set yet. But so then we can pull in our exact same data set as we did, except with our test CSV, pull that in, and then make predictions based on that data as well. And that's what we can inevitably submit to the competition itself. So I think that's kind of the basics of what Abid did and the setup that he had for the project itself. This is something, again, that it's a good layout for the it's a good intro into our competition in general. So again, anyone who's interested, we're doing a $1,000 grand prize to any Deepnote notebook that's published in the month of April. And that can be anything in the data science realm. So it could be data visualization or machine learning, or something that's even breaking down a common library that we use in data science. So we look forward to all your submissions there. And I really appreciate everyone that joined us on the stream tonight, especially Abid and Alan. Thank you so much for your help. The discussion was awesome, and jumping on and talking through things. And I think that's all I got for right now. You guys?
Well, this is a pleasure. And yeah, Abid, you rock, man. Thanks for all the help.
Making data science easy again. Love it.
Yeah, actually, I learned a lot from this. This is amazing.
I certainly did too. And I kind of like this environment of us talking through stuff and figuring out different things and helping each other when we're kind of new to different things as well. So it's a very open environment to ask questions. No stupid questions, for sure.
No, yeah, it's very nice. Yeah, thanks for facilitating, Jacob. Appreciate it.
All right, thank you guys. Have a good rest of the night.
Okay. Take care. You too.
See ya.